Hello everyone, myself Dr. T. Rajani, Faculty of Physics from Vienna JYOTHI Institute of Engineering and Technology. Today I am here to deliver a talk on Introduction to Nanoscience and Nanotechnology. In my talk, the presentation goes in this way. First of all, I would like to introduce what is the difference between the macro, micro and nano. Then nanotechnology, how many different types of nanomaterials are there, and how we can divide the nanomaterials. What are the main important properties of the nanomaterials, like surface to volume ratio and quantum confinement, and what are the physical properties which we see the change when downscale to the nano size. So if we look at the picture here, there is a division between the macroscopic, microscopic and nanoscopic particles. Macroscopic, microscopic, nanoscopic bodies also we can consider here. Here if we see, the macroscopic particles are the particles which we can see with our naked eye, and microscopic particles requires some kind of instrument in our hand to see them very clearly, and same as the nanoscopic particles requires much higher precision instrument to understand the nanoparticles. So if we look at the picture over here, the nanoscopic particles are in the range of which we cannot see with our naked eye, are in the range of 0.1 nanometer to nearly 10 micrometers, which requires an electron microscope to see them. So the best examples for them are the lipids, proteins, atoms, viruses. They come under this scale. And coming to the microscopic particles, they are in the range of 100 nanometers to 1 millimeter. But although they are 1 millimeter, it is very difficult to differentiate them. So for example, you can see the bacteria, mitochondria, or any kind of flywheels, eggs. So there comes under the microscopic scale. And coming to the macroscopic scale, which are very much easily visible with our naked eye. They don't require any kind of instrument. So this is the division of the macro, micro and nanoscale. So in today's world, we are going towards the technology advancement. We are learning how this nanotechnology helps us in the better living of the society. So this is the differentiation. Now coming to the next one, what is a nanomaterial? So a material is termed as a nanomaterial if the size, or if it has at least one dimension in the nanoscale range, 1 to 100 nanometers. For example, you can see again here I have presented one example of different pictures where the 1 nanometer range is in the DNA. Human DNA is in the range of nanoscale. And then coming to the proteins, then coming to the carbon nanotubes, which are very much used in every product in today's world, which is in the range of 10 nanometers. Then coming to the silver nanoparticles always in the nanoscopic range, which are very much treated as antibacterial. So people suggest to eat in the silver plates, drink the milk in the silver glasses, like that, since they comes under antibacterial when they are treated at the nanoscale. Now coming to the micron scale also, we can see the bacteria which is there in our body, then red blood cells which are there in the range of 10 microns, and then the plant cells, animal cells are in the range of 100 microns, and the human hair is in the range of 1 millimeter. So this is the division of the different scales. And now in today's class, we are going to learn what is exactly the nanomaterial, why it is having so much importance, and what are the applications of these nanoparticles, why there is a need to, where we can see the applications of these nanoparticles in every area. So you can see here there is a diagram where you can see the advantages, you can see the applications of different nanoparticles in every area, whether it is in the renewable energy sources, where we are treating them as energy storage devices. If you are going for the mechanical industry, welding and joining industry, we are using them. If we are going for the textiles, we are using the nanofiber fibers in the making of the different products, different clothes, where and then coming to the next one, you can go for the medical, because to treat the high-end diseases nowadays without affecting the other organs of the body of animals or human beings, nano capsules are used. So these are all the different food and agricultural industry, where you can sense the bacteria very well by using these nano sensors. So these are all the different areas of the different areas where the nanoparticles are used. Now coming to the next one, what is this nanotechnology? Any product you prepare at the nanoscale and use at the target and in the making of any device, then we say that nanotechnology is used, nanotechnology is developed. So any form of technology which is using the physical dimensions or in the order in the between in the order of 1 to 100 nanometers, we say it is a nanotechnology. So first of all, we prepare the material, we prepare the structures, then we can use them in the devices, then we can use them in the development of the systems also. So this is the nanotechnology. Now coming to the nanomaterials. So different types of nanomaterials are present across the globe. So in that, some are naturally occurring, some are engineered materials. So coming to the naturally occurring nanoparticles, so usually by accidents or by chance, whenever we are doing some kind of works, you can observe these nanoparticles in the forest fires, in the sea sprays, mineral composites, in the volcanoes. Whenever the volcanoes are we are having so much of ashes. So these ashes are in the range of nanoparticles or nano size, nano range. And any kind of virus you consider, it is in the nano range only. For example, the recent 2020 is an era where we remember every time. It is a coronavirus. It is in the range of nanoscale. So it is very tough to overcome of that. That is the best example we can give for the viruses over here. So these are all the naturally occurring nanoparticles. Whenever there are some kind of chemical reactions in the environment, these kind of nanoparticles are occurring in the environment. Coming to the next one, the incidental. Whenever we are doing some kind of work, automatically some nanoparticles or nano fumes are produced in our reactions. So for example, whenever we are cooking in the kitchen, smoke is coming out of it. The smoke, when we predict, it is in the nanoscale. So now coming to whenever we are going on the car, whenever we are having the diesel exhausting, the pollution is created. That pollution is in the range of the nanoscale. So that is why people say that, because since these nanoparticles are termed as the very small size, they can easily go into the skin pores of the human beings, of the animals. So it is suggested not to stay in the pollution area for more than not to spend more time in the long hours in the pollution area, because they can harm the lungs, they can harm any part of the human body. So that is the reason why we have to avoid more pollution. Air pollution is more dangerous. Next, coming to the welding fumes. Whenever we are doing some kind of welding, whenever we are joining any two metals, some fumes are coming out of it, and it is also in the nanoscale. And industrial effluents. So industrial effluents, all we know that they are more toxic in nature. So whenever we inhale them, again it is going to affect the people surrounding the industries. And then sandblasting. All of you are aware of this sandblasting very well. Whenever there is a sandblasting is there, large amount of ashes, large amount of sands are coming into the air, and which can cause very much damage to the people around it. So these are all the incidental nanoparticles. Means whenever we are doing some kind of reactions, whenever we are doing some kind of works, so these kind of incidental nanoparticles are coming into the picture. Now coming to the next one. So the third important one is engineering. I want to have a kind of a 1 nanometer wire, or I would like to use 1 nanometer, 2 nanometers sheet in my product, or I would like to use 10 nanometers nanoparticles in the, what do you say, for the pigmentation of my skin. So these are all the kind of engineered nanoparticles which are done for some kind of target, These are prepared like an experiment in the lab. We can prepare them. So whatever the size we require, whatever the shape we require, how much, whatever the requirement we have at the target end, we can engineer them in the lab level. So these are called as human origin engineered nanoparticles. So for example, you can have a metal nanoparticles, you can have a quantum dots. Quantum dots are the particles which are used exclusively in the medicine, which are used in the medicinal pharmaceutical industry. Then these are used for the nanotubes. Nanotubes are having a very high applications. They are used in the energy storage applications. They are used as an electrodes also. And these nanoparticles which are engineered, or nowadays they are using in the sunscreen lotions to avoid the ultraviolet rays which are causing harm to the skin. Then you have a Ray-Ban glasses which protects you from the UV rays. So these are the thin films which are covering the Ray-Ban glasses, which protect you from the sun rays. Then nanocapsules. Nanocapsules are used for the drug delivery. These are used. These are some of the examples of the human origin engineered nanoparticles. So first of all, let us understand how these nanomaterials are divided. So exactly how we define a nanomaterial, how we can say that in my product nanomaterials are used. So for example, you consider a cube over here, x, y, z dimensions. You consider a cube of x, y, z dimensions. Okay. So if three dimensions are in the nanoscale, we say that all the parameters are in the nanoscale, then we say that that is a three-dimensional nanoparticle. Then we say that is a three-dimensional nanoparticle. For example, x-axis is also nanoscale, y-axis is also nanoscale, z-axis is also nanoscale. Then we say that that is a three-dimensional nanoparticle. So best examples are nanoshells and nanorings. So these are the best example. Now coming to the 2 dimensions, if only 2 dimensions, only x and y, or y and z, or x and z are in the nanoscale, and the remaining 1 dimension is in the any other scale, like from millimeter, micrometer to any other scale, doesn't matter. We say that these are 2-dimensional nanoparticles. So only length and breadth are in in nano dimension. The other height is in the other dimension. Then we say that it is a 2-dimensional nanoscale. So the best examples are tubes, fibers, and wires. So these nanofibers, nanowires are used in the nanosensors, and nanofibers are used in the textile industry. Now coming to the 1 dimension, only 1 dimension is in the nanoscale, either x or y or z. But then also we can define that as a 1-dimensional nanoparticle. So there is no need that all the 3 dimensions should be in the nanoscale. Any 1 dimension, if it is in the nano range also, we say that it is a nanoparticle, it is a nanomaterial only. Now coming to the last one, which is a 0 dimension. 0 dimension means dot. There is no length, there is no breadth, there is no height. Still we say that it is a nanomaterial, but of 0 dimensions. Usually we say that 1 to 2 nanometers, 1 to 10 nanometers, we consider that as a 0 dimension. Sometimes the research says that 1 to 5 nanometers also can be considered as a 0 dimension. These 0 dimension particles are usually used in the mainly targeted drug delivery. For any kind of target medicine, they are using these kind of 0 dimensional nanoparticles. So the nanomaterials are divided into basically into 3 categories, but we can include the 0 dimension also, which are used in the targeted drug delivery. Now coming to the next one, why the nanotechnology is having so much of importance? What is the basic reason? Why not for macroscopic, microscopic not having that much importance, but still why small is becoming so good to us? So before I go for that, why small is good, let us understand this with simple example. So in this example, you can see that all of we are aware of the gold. So gold is an yellow metal. So by macroscopic nature, when we look at the gold ornament, it is always appears in the yellow nature. It always appears in the yellow nature. But if I start decreasing the size of the gold particles to the nanoscale, it starts appearing in the red color. It starts appearing in the red color. So here at nanoscale, if we want to use an ornament, it will not be appearing in the yellow color, but rather than it is going to appear in a red color ornament. So with this we can say that the nanoparticle, whenever you decrease the size of the nanoparticle, there are changes in the surface, there are changes in the physical properties, there are changes in the chemical properties. So that's why color is changing, size is changing, and it is becoming more active, it is becoming more reactive also. So that is why these gold particles, silver particles, all of them are used in the Ayurvedic medicine also. Now coming to the next important one, let us understand why small is good with this help of with this diagram. So you can see that as consider it as a football, and the football is made up of some shells over here. So as the number of atoms are surface atoms, as the number of size of the shells are decreased, to make any kind of football, the number of atoms on the surface, you can see here, the number of total number of atoms which are there are also increasing. Shells are increasing, total number of atoms are also increasing in each and every shell. But the size of the shell, the size of the atom is decreasing. You can see more number of atoms are appearing on the surface. More number of atoms are appearing on the surface. More number of atoms are appearing on the surface. Here you can see when more number of atoms are appearing on the surface, surface becomes active. Surface becomes active. Surface becomes active means chemical reactions becomes more active. Chemically it becomes more active. Physically it will participate very fast in all the reactions. This is the main reason. So the foremost important property of the nanomaterial is surface area increases as size decreases, which is termed as a large surface area to volume ratio. Large surface area to volume ratio. So the first property of the nanomaterial is large surface area to volume ratio, because the surface is becomes more active, because as more number of atoms are appearing on the surface, it becomes physically, chemically, it becomes more reactions. It participates very fast in the reactions. Now coming to the second one. The second most important property is quantum confinement. This quantum confinement is observed when the size of the particle is too small to be compatible to the wavelength of the electron. So when we consider the wavelength of the electron, the size of the particle is very less. Size of the particle is very less, and it becomes equivalent to the wavelength of the electron. So that's why what happens is all the particles will be squeezed in a very small area. All the particles are squeezed in a very small area. So this can be understood with very well with the help of a band diagram. So as we know about the semiconductors. So in the semiconductors, we know there is an energy level diagram is there. In that, this is termed as a valency band, and this is termed as a conduction band. Usually the valency band and conduction band appears in this red color. So the width of the band is very high. So, and you can see the density of the band is also very high. But as the size of the particles are decreasing over here, what happens is the band starts getting squeezed. The band starts getting squeezed, and the narrow of the band gap becomes so narrow. It is confined to a very small area. It is confined to a very small area. So as the size of the particle here decreasing the particle size, you can see as it goes to the violet color range of the particle, what happens is the band becomes so narrow and the band gap starts increasing. Band gap starts increasing. So quantum size effect occurs when the nanostructures themselves become smaller than the fundamental scale. Smaller than the fundamental scale. So it is this kind of property is defined as a quantum confinement. This is one of the property which is also forms as a basis to understand quantum computing also, which is another technology, which is upcoming technology nowadays. Quantum confinement is also used as a basis for quantum computing. So the second important property of the nanomaterial is quantum confinement. The first one is large surface area to volume ratio. The second one is quantum confinement. Now coming to the next one. What are the, so we know that as the most are tunable with the size, as the size of the particle is reduced, so surface atoms becomes more active physically, chemically also they become active. They participate in all the reactions very well at a very faster rate. And as the size of the particle is decreased, the quantum confinement also happens. The first and foremost important thing which we can observe that our material has been in the nanoscale is the color. Color is a property where we can, at a glance, we can observe it. And the second one is you can observe size, space, shape, surface area, aspect ratio, agglomeration, aggregation, size distribution, surface morphology. Surface will change, so structure will change. Solubility, the way it is becoming more soluble, it will change. It will change its color, it will change its density, it will change its hardness, melting point, boiling point. All these properties are going to change with whenever the particles are decreased to the size of nanoscale. So they, I can give some of the important properties where we can observe at a glance. First one is the lower melting point, or phase transition temperature. Phase transition temperature due to huge fraction of surface atoms on the surface. The second one is the material becomes so high in strength when compared to the macroscopic and microscopic particles. So the mechanical properties of the nanoparticles reach to the theoretical strength level. So the enhancement of the mechanical strength is simply due to the reduced probability, because of the defects are reduced, because all the particles are coming and close to each other. The defects, the volume defects or the surface defects will not be there. The volume defects will be reduced. The void spaces are reduced. Because of that, the strength of the material will be enhanced at a very maximum level. Now coming to the optical properties. Optical properties, the best example which I have told you is gold. You can see how the change of the color of the gold metal, yellow metal is changing, right from yellow to red color. So that itself indicates the color of the metallic nanoparticles may change with their sizes due to surface plasmon resonance. And the electrical conductivity, as more number of particles are participating in the more number of particles are increasing, more number of particles are participating at the semiconductor level or at the conductor level. So increased surface atoms are there. Electrical conductivity of nanoparticles could also be enhanced appreciably due to the better ordering of the microstructure. Now, these nanomaterials are more magnetic than bulk materials, because the paramagnetic materials, or you can see some of them, they exhibit very high magnetic induction also. When used in the magnetic sensors or when used in the transducers also. So overall we can say that whenever you prepare a nanoparticle, whenever you prepare a nano powder, or whenever you prepare any material the nanoscale range, generally all the properties are getting changed over here. So which makes it to use in the kind of a structure or in the device or in the making of any kind of system. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.